So Veruca is a chemist and wants to end up with 50 ounces of a 22% solution. She has 25% solution and 15% solutions to mix together. How many of each type of solution should be mixed to obtain the 50 ounces of 22% solution? Well, if we define our variables and write it down, then we won't get confused about what each of those variables is representing. So we need to come up with two equations for our system of equations since we have two variables. Well, the first one's pretty straightforward. We want to end up with 50 ounces of solution. So when we add the x ounces to the y ounces, we should have a total of 50. So x plus y should equal 50. The next part is not quite as clear. We want to come up with how much of the actual chemical is coming from our x ounces of 25% solution and our y ounces of 15% solution and see what we end up with in the end. So, of the x ounces, if 25% of it is the actual chemical, then that's going to be 0.25x. And 15% of the y ounces is the actual chemical, so 0.15y. That's how much of that is in the 15% solution. Well, that should equal what we get, the amount of chemical in the final solution should be 22% of the 50 ounces. So that should be 50 times 0.22 or 22%. And then if we take our first equation and solve for x, then we get x equals 50 minus y. And we substitute that into our second equation, then we get 0.25, but instead of writing x, we're going to write 50 minus y plus 0.15y equals, and we can see that what that actually equals is 11. Now we have our one equation and one variable, which we can solve. Again, at this point we should be able to solve one equation for one variable, but the details are listed below on the webpage. So we solve this and we get down to the point where we see that y is equal to 15. And going back to our original equation of x plus y equals 50, well, once we know that y is equal to 15, then that means x is going to have to be 35, which means we have 35 ounces of 25% solution and 15 ounces of 15% solution, which seem like reasonable answers when you go back and reread the original problem. And also we could double check everything specifically by plugging these two values for x and y into both equations.